Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I am going to teach you some algebra right now. This is the replacement video for lesson 4.7 on piecewise functions, in which we ask the essential question, how can you describe a function that is represented by more than one equation? Well, first we have to talk about what a piecewise function is. And a piecewise function is a function defined by two or more equations. So it's going to look like this. And we have, in this case, we have two equations. We have this one and this one. And which equation we use depends on the input value we're going to use. And the input value is defined over here. The domain is split into two separate sections. In this case, if x is less than or equal to 0, you would use the first equation, and if x is greater than 0, you use the second equation. So let's take a look and see how how we would use that when evaluating a function like this. Okay, so in this first example here, we have a piecewise function. It says x minus 2 if x is less than or equal to 0. And 2x plus 1 if x is greater than 0. Well, what are we going to do here? So we have two separate input values we're going to use, 0 and 4. Well, when we use 0, which one do we use? Well, we look over to our domain definitions here, and it says if x is less than or equal to 0, use the first one. So we're going to use the first one because x is equal to 0. So f of 0 is equal to 0 minus 2. So f of 0 is equal to negative 2. When x is 4, well, that's greater than 0, so we'll use the second equation. So f of 4 is equal to 2 times 4 plus 1, which is 8 plus 1. So f of 4 is equal to 9. Okay, so that's evaluating a piecewise function. What about graphing a piecewise function? Right, so here we have this piecewise function, y is equal to negative x minus 4 if x is less than or equal to 0. So maybe one thing we can do here is to just graph this first and then determine where we want this, where we want to keep the graph. So negative x minus 4, this is what? This is a y-intercept of negative 4 and a negative slope of negative 1. So it's going to go along this kind of line like that. Let me get me a good line here. Okay, but the thing about this is, let me try to fix this here. This is for x is less than 0, not equal to 0. So this is not going to include where x is 0, so this is going to be an open circle over here. And then for the second part of the graph is just x, so slope of 1, y-intercept of 0, right? 1x plus 0. If x is greater than or equal to 0. So our y-intercept is 0. And they're going to use a solid dot here because of the equal bar there. A slope of 1 takes us up like that. So this should go something like this. Okay? So in this case, the domain is all real numbers. We can look at this two ways. You can look at the graph and see that it's going to the right infinitely and to the left infinitely. Or you can look over at this section over here. This covers everything. The numbers are either less than 0 or greater than or equal to 0. There's no gaps in this section here, and there's no gaps in our graph. And the range here will be y is greater than 4. Y is greater than 4. Okay. Again, we've done the domain and range stuff before, so in this case, everything is above the 4. And there's no gaps in the y's here, so y is greater than 4. All right? Now in this example, we're going to write a function given a graph. So we have to look at the two pieces of the graph here and determine what the equations are. So I'm just call this f of x, I guess. It's equal to, this first, I'm going to do the one on the left here first. This looks to have a slope of 1. Up 1 over 1, up 1 over 1. It has a slope of 1. So 1 times x. And my y-intercept here is 3, x plus 3. Now, that's going to be used if x is, now, we're looking at our scale down here, our x scale. X is less than, but not equal to, 0. The second equation has a y-intercept of -1, and it looks to have a slope of 2 over 1. 2 over 1, right? So a slope of 2, so 2x minus 1, and that's going to be f if x is greater than or equal to 0. I'm looking at this part of the graph. It's to the right of the y-axis. That's where the positive numbers are. So y is greater than or equal to 0. Okay, so there's this one. So we have to go back to our ability to look at slopes, to look at y-intercepts, and write those functions. And then look at where they are on the x-axis, and then write our inequalities for that. Okay? And that's it for this video. Those are the 3 examples. There were some errors on the earlier one. So this is the replacement video. The next video has to do with step functions. All right? Thanks a lot and have a great rest of your day. Bye-bye.